Okay, I want to cover some wiring configurations for the legacy low voltage lighting systems that I'm always talking about on the channel. Please excuse any background noise. I'm in the shop as usual. So what I have here are two different systems, actually. I have the system that was in my home, which is this one, which is not currently wired to an actual 120 circuit. This one is. I'll get to that in a moment. This was found inside a relay box in my basement. Most systems will have these relays, and they'll usually be in central-ish locations. I say ish because some of them are in attics, and some houses have more than one box. I have that one wired up to the bottom switch here, and then I have the top one wired up to this relay. This is actually from a home in Michigan. The homeowner was kind enough to give me one of his, well, two actually, of his old relays, and one of them I took apart so that I could see what was inside. You've probably seen that in another video. I'll talk about that here in a moment as well. This one I have wired up, and I actually do have connected to a circuit, and I have, so you, oh, whoops, helps if I turn it on. And you can see, okay, that behavior, by the way, is not indicative of the switch as I originally thought. It actually has more to do with the way that this guy works, and that is that it has a tensioned wire running from this, come on, focus down front, okay, from this little guy here. It just runs down and mounts to these little rivets. I've broken these playing with it. Come on, focus. Focus. There we go. So underneath is where the actual sort of snap action device is, and it's sort of wimpy. And you can kind of see, I'll just lift this up because this thing is just junk anyway. You can see the contact there. It's sort of awful, actually. It looks like a decent contact plate, but this whole situation, everything about this is soft. And there's a reason for that, I suspect. One thing that I noticed when I was setting this up, when I run that relay, I don't know if you'll be able to hear it. So that one is one of the ones that was actually failing in my system. And I think it's finally seized. Yeah, it sounds like it finally seized. It won't click anymore, but it clicks fairly loud when it works right. This one, you'll notice, very rarely emits an audible click, and usually it's when it comes on, not off. And that's because of the direction of the tension, focus, on that little lever inside of there. Right, so you can kind of see how the snap action device works. It has tension on this guy, and then when the wire is pressed, it pushes it back and forth. Not very good. Not very good at all. And there's a lot of arcing, a lot of evidence of arcing in here. Can we see it? Yeah, you can see it there. All that white carbon scoring. So, what to do in these various situations? All right, let me get back to the differences. So, this relay, again, in a box, this relay in the fixture where the light is, or in line in that fixture with the fixture and an outlet, or some combination of those things, which is how I have it wired here. So as you're imagining this, this relay is inside of a box somewhere. This relay is inside of a fixture in the ceiling where your light is mounted. These wires coming out, this wire goes to the light. The neutral is split between this and the light, and then there's a hot going into this, okay? So you'll have 3 wires there. If you wanted it to just be on, you could just wire the hot straight through and put a switch somewhere, if you can do that. That is an option, not my favorite option. And then you'll have these 3 wires coming from the switch. The colors of these wires and the order that they're in varies by manufacturer and installer, and it's kind of crazy. The ones that were in my house were this way, okay, where the black was the common, the red was the on, the white was the off. And that's they're opposite of the direction the switch goes in the desperate case, right? So that's up, that's down. Yeah, or this is the top contact, that's the bottom contact. Okay, so getting back to the wiring portion of this. In this system, you have another component. I haven't talked about this yet. The transformer. The transformer is coming off of the 120 volt line, stepping it down to 24-ish, it's more like 28 volts, and then that is going out. Now, you'll notice on this terminal block, there is one significant difference in the wiring. The hot or common, who knows, they didn't seem to know or care in my system. They weren't marked for polarity, but maybe they just knew based on where the wire was. The way that it should be is the hot gets switched, but anyway, the hot is running over here, and you can see that the hot from the transformer goes out to the switches. So in my relay box, there's a wire that comes from the transformer over to the relay box, because the transformer's in another room, comes over to the relay box, and then it just pigtails into a ton of these other wires that go out to the switch. Okay, and that's why I have that jumped there, because they also connect to the relay, and they connect to the center pole of the relay. Then the other 2 wires come out and go out to the switch for the up and down. So that's a little bit confusing. Maybe rewatch what I just said. But the hot from the transformer basically goes out to the switch and gets switched between the red and white wires here. The black wire comes from the neutral off the transformer and goes out to the relay. And the reason is because the relay is split into 2 sections. It's split into 2 coils. One does the pushing, one does the pulling of the snap action device inside. These are amazingly robust. They're not super, they weren't built within super great tolerances. When I did the test on this relay, because the colors are different, this is a, which one was this? Okay, this was an early GE. So it was similar to this one here, which I know is dead. And then this one is a later one, and it has a different wiring color. The blue, the white is blue on that one. But anyway, those come back, and then those go into the transformer through those. So the circuit, this is the device and the control at the same time. And then this is the input. So that is a fairly easy situation to get around in multiple ways. You can change this out for a solid state relay like this and give it continuous power through a toggle switch, and it's DC, so in order to do that you would need to install one of these, which I'm going to do a little bit of hands-on here in a minute. This is a full bridge rectifier. That's not your only option. There's other options. In my system, I've done a couple different things. I'm actually using these. And these, I think, are actually the best solution for both of these systems, but it's complicated. I'll get into that in a moment. So, inside of this relay, the reason that you only have, if you've been paying attention, there's no relay box involved in this system. The wire goes straight from this relay to the switch, which means it goes from the fixture across the ceiling, down the wall, and to the switch, and that's it. So you don't have a power supply to go to it because the power supply, the transformer, is inside of the base of this relay. And that's what it looks like. It sits inside here. And I've done some testing. It seems to run at between 6 and 8 volts. So it's a lot lower too. This system uses 24 to 28 volts or 24 to 30 volts. This one uses probably 6 to 9 volts. I don't know what the drop-off currents and all that are because I didn't. You could look that up. It's probably documented. I don't care because I'm not keeping either one of those relays in my situations. You can get replacements for these. Some of them are cheap, some of them are not. The replacement for this guy, usually between $70 and $90. The replacement for this guy, $380. Which is insane because I have pulled apart the replacement for that. And all that's in it really is a little opto-isolator circuit with a control line and an even smaller transformer than this. And I think this guy was $3. So, I mean, it's got a big heat sink and it's been through its ratings and all that. So, good on them. But I don't think I don't think $380 is a good price for that. Especially when you can get these and these for around $20 to $30, right? So, this is the Shelly 1 PM. There's a significant difference between the 1 PM and the 1, and that is the 1, if you pull this little window off, has a selector that allows you to select between 12 and 24 volts. This one does not. It will, however, run off of the voltage from this guy, as long as you put in place this guy, because it doesn't want 28 volts AC, it wants DC. So, we will do that here in a little bit. I want to cover using this. So, in my system, I have removed my relays, connected one of these in place, or there's a couple different devices I use. And then this sits in my relay box where the wires from the switch come in. They go to this, but they don't go directly to this. And this is where my limited understanding of code and standard practice as an electrician is a shortcoming. I don't know. I know theoretically that running 110, 120 through the switch wires for this should be safe. I am doing that in a small control box that I built. I am using Cat 5 wire because it's current rated for as much current as this device will allow through it when it's being switched. I don't want to give that as advice, but I believe that it is safe. However, because of my not sureness, and because there are so many wires run throughout the house, and I'm not sure if there are breaks in any of them, and you just don't know what could happen, I use an intermediary relay. And what I do is, on this side, I have taken a full bridge rectifier, created DC, and then run that DC just like this is wired, but instead of going back to the center pole there, I'm going here with the ground, and the hot is running out to the switch, and is switched. And I'm only switching one. I'm not using the down position. I'm only using the up position. So when you hit it, this turns on and off. And there's a little LED in there. You can actually watch it. You've probably seen it in other videos if you've watched my videos. Then I use heavier gauge wire from this, the actual contacts that this is switching, to switch for the inputs. I could do the same thing with this and not use that and just have a direct relationship between these. And you could do this with a Shelly 1, a Shelly 2.5, or a Shelly 4, etc. However, one of the reasons why I'm doing it this way is because I can then use my MQTT server or broker to get messages from this to relay to basically what is my brain in my system that then knows what to do based on different things you can do with the inputs. Short press, long press, single and double press, etc. Also, eventually, I'm probably going to step that up and do something even more way over-engineered. Rube Goldberg would be proud, but I think I have practical reasons to do it. I'll explain in a video when I do the video for it. But that is using those same wires, or that last wire, more importantly, because I always have 2 switches or more, as, where did I put it? In conjunction with a 5-volt power supply, or step down. I'll take this and then I'll use a voltage regulator. And then I will put these in. And these are logic level converters that I will then use to connect to the UART of Raspberry Pi Picos. And I will create a network, a serial network of Picos without Wi-Fi that can talk to one another and execute commands and do all kinds of things. And also have inputs from buttons and sensors. The other really cool thing about these is they have onboard temperature sensors, which means I can get a more accurate picture of the heat gradient throughout my building. But anyway, so that's coming up much later, but that's another thing that you can do. So that is what I have done there. With this system, without, ignore the transformer, with just this system, right? You can do the same thing. However, there's a couple considerations. See, this thing just does not like being turned off. If you put this in place of the relay, that's fine. But now you have the switch situation to deal with, and you don't have a lower voltage. You could add one of these. Recently I spoke with a homeowner who is going to go this route because his buttons have 12-volt LED lights in them, and they light up when they're on or off. Anyway, they light up. He needs the 12-volt off of this, and he needs to use it with a Shelly 1 because this won't power one of these. But that fits in his little, very, very tiny, like 3.5-inch round pan conduit that holds his fixture. So you could use something like this and run that down and then run it back and then add another relay to act as an input for this. Or you could use the 1 and you could just power it and use the switch for the switch. Or you could just install the Shelly, and I'm not suggesting you run the 110 through your switch wires, but it is theoretically possible. Or you could use this in conjunction with one of these. But again, you need some kind of power supply. So if you were going to go this route, this, in my opinion, is the better way to go. And what I would honestly do is I would put this in the fixture, I would put this in the fixture, run the power down to your switch through that. Don't worry about the other wire if there is one. Put this and these in your switch. Well, no, I take that back. You can't do that. So, sorry, here's the other drawback. No DC capability on this guy. They do offer other devices that you can do that with. I believe the Shelly Uni you can, but it's a little bit more involved. It's a little more do-it-yourself, not as plug-and-play as this. So yeah, you would almost certainly have to have this and this and this in your fixture box. Well, you'd have to have all this in your fixture box. So that's not a whole heck of a lot of room. These three things you could get away with and then have another circuit to switch down to the wire, right? Like an opto-isolator or a smaller relay. This is a big relay, so you wouldn't necessarily have to have that. And this is a problem that I have been thinking about for almost 2 weeks now, and trying to come up with the best solution, which I believe is really just this with a Shelly 1 out to the relay, or out to the switch. You know, you just run the power out to the, you run a power to the Shelly 1, ground to the Shelly 1, you know, hot to the Shelly 1, ground to the Shelly 1, and then split off the hot and run it out to a switch, and then what's coming back from the switch goes into the SW terminal of the Shelly 1, not this guy, unless you have 30 volts, in which case, go ahead and do that. But, yeah. So I'm going to go ahead and, what am I going to do here? I was going to do something. What am I going to do? Shut that off. Let's get that out of there. I want to take the relays out of this equation. So let's just take the relays out of the equation completely. Completely disconnect the power back there just in case. Grab this guy, and let's get the relays out. Okay, get those out of there. Now, what we have here is in the situation with the transformer, we still have a wire coming from the transformer and going out to the switches. We still have the two wires coming from the switches. Okay? And then in the transformer-less situation, in the REMCON, we'll just call it the REMCON situation. That's what the that's what this guy is. It's an old REMCON. In the REMCON situation, you now have a hot and a neutral from your 120, a red wire or another wire that goes out to your fixture. You probably have another neutral, but it'll be tied together with the neutral that went to the relay. And then you'll have 3 wires coming from your switch. In this example, the black is connected to the common, or the input on the switch. The red is the upper, so flicking the switch up and the black or the white is flicking the switch down. So you could, since there are two here, theoretically run a wire. I'll go ahead and do this. Why not? Again, I am not advising that you do this. If somebody else knows for sure that it is safe, please comment below. Supply some source material to back it. I am going to do this for this example just to show the simplicity of it, and I may go ahead and wire in the relay as well, but I'm just showing how this is done. Okay, so we only need one neutral wire to go to the. I should have put down a mount for this so it stayed put, but I didn't. Okay, so we have our neutral wire. Then we need a hot wire to run to the Shelly, and I'm going to do a thing here. Instead of wiring from my hot that's coming out of, because remember this is coming out of the fixture, it's these big thick guys, instead of running another wire off of that out to the switch, I'm just going to come off of this other L terminal. These are connected inside. So let me grab some more wire here. And my camera's doing that thing where it likes to cut out. Yay. So I'm going to run this hot wire in this terminal here. Okay, and that is going to go out to my switch center pole. Now I'm going to run another one of these. I'm going to jump this to the center pole of this switch later. Well, I may not do it. You can do that. Let me just put it that way. You could do that so that you can have all four line ins here. And I'm also running this as though I want the oh, you know what? Let me do this. Let me do it the proper way here. So this would be your white, and I'm going to go into switch 1 with that white. And then I'm going to go into the red. Well, no. I'm going to do it color coordinated. Okay. And again, you could do this in whatever order tickles your fancy. And then go into switch 2 with that one. And then you see where I'm going with this. You could then go white-red for the next switch into switch 3 and switch 4. So now that's it. This now understands the switch inputs from this. So then you would simply run another neutral over to this Shelly, and then you would run another hot to the Shelly, and then you would come off of the L. Well, you don't even have to. You can come off the L and the SW the same way you did here and not do this, or you just go from the output out to your light and you're done. Regardless of this situation, this is the way that you want to do that. You want to run a wire from the hot to the L on here, from the neutral to the N on here, and then your red or load wire out to your light goes into the O, or the output, on here. That is true for all of the Shelly devices, including the dimmer, which I have. Using the dimmer, though, you want to make sure that you have light bulbs that support it. So if you're using LED bulbs, make sure they're dimmable. And that's another great use for the two-way switch, because you have two switch inputs for bright and dim, right? So again, I would wire in the intermediary relay instead of doing that, but maybe that's not necessary. I would love to know for sure whether or not that advice is okay, because like I said, what I do, where'd it go? What I do looks like this instead. I do have that set up. Where's my other? And I'm just going to take the red off of here because I only use one per switch for one. And then the load, and I use thicker wires than this for this part, right? What direction are we here? This direction, so. And then I have a DC power supply using one of these guys. So if you take this out and this out, and you put the hot going out to the switch, and the ground going to the coil. Then these Yeah, look, I'm not a huge fan of wire nuts either. And this is just demonstrative. Probably not even going to run this. Well, I guess I could just to show you. Okay, so I have that running to that. The hot running over there, and then I take another hot. You know, we'll go from, well, I'll go from the red wire, that's fine. So that went out to the switch, and then the red wire comes in here. And runs to the coil. And now your switch wire no longer handles the 120 volt because the relay does. Make sure that I'm not... Yeah, so oh, I didn't plug it in. Okay, so, oops. Let's go back to here. Do I have that correct? Fairly certain I do. Okay. Well, I have done something wrong here. I'm actually going to pause the camera and check that just because I'm running out of time. Let's see, so let me do that again. Seven and 8, ground is 8, 7 is hot, coming from your DC, so coming from the switch, you're hot, and then 5 and 6 down here are coming in, and then you have a normally open, which is 3 and 4, and then 1 and 2 are normally closed. You don't want to use 1 and 2 for anything. You want to go straight through. The reason that I had that turned around is that the system that I looked at the last time was going the other direction. They were hooking the hot up to the normally open, and then the load out to the fixture to the input of the relay. And the reason they were doing that was so that you couldn't accidentally hook something up to the normally closed and have it powered, because it can never be connected to the hot that way. So that's the answer. There's that. I'm not sure why that didn't work. My guess is that this transformer is just not supplying enough current to engage the coil, which is probably the case, because these guys are, well, this guy's rated for 12 volts, but these ones are rated for 24, so they should be fine to run off of that. There's another way to do, there's another option. I'm not going to talk about the configuration and the wiring because I don't like them anyway, and I like looking at them, but that's about it. And that's this guy. If you provide constant power to one of these, you don't need the rectifier, because this uses 24 volt AC. I don't like that at all, because that leaves the circuit live in the wall. But it is an option, I guess. Or you could use it as the momentary with the Shelly, right? And just use your 24 volt coming off of your transformer. So I can't remember how much this was. I get most of my toys from a company called Midwest Surplus here in Ohio. And my camera cut out. Anyway, I buy this stuff from Midwest Surplus. I'll link to them. They're cool. That's it for this video. That was very rambly. I hope that you got something out of it. I hope you enjoyed the video. If you did, Please subscribe to the channel. Please like. If you'd like to see more and better videos, please consider becoming a patron on our Patreon page, linked below. Until next time.